So hi, my name is Martin Volovar. I am from Slovakia University of Technology. In our approach, we generate a high resolution model directly on GPU. It's faster than generating on CPU. Generated geometry is adaptive, so it depends on view dependent. We can animate with surface changing control points on displacement map. So if you are interested in, you can.
Hi, I'm Peter Boroves from the Budapest University of Technology and Economics, and I'm a man who doesn't believe in the tireless pursuit of the best soft shadows and most realistic soft shadows. Instead, I like my shadows with a real hard, like drawn out black counter. So I implemented an algorithm that renders cast shadow counters in real time, and this could be used for artistic purposes also, aside from my preferences, of course.
So hello, I'm Lucas, and I'm just going to tell you the story, so please focus on the line. There's a video I made. So Claudia is a designer, and she has to create a visual style for a mobile molecule rendering app. Lucas, an engineer, like me, has to implement it. As soon as he's finished, Claudia already drawn 2 more other styles for other target groups. So Lucas has to do the whole work again and implement everything again. Wouldn't it be better if Claudia could do it on her own without Lucas? If you want to know how, come to my talk on Monday morning, afternoon, to see how it's done. Thank you.
Hi, my name is Dennis. I present an interactive comparison tool for time-dependent data. So imagine if you have an image and you want to analyze it, you can take more or less as much time as you want. If you filter it, you get a multiple outcome, but still, if you want to compare it, just look at every picture. But if all these images are moving, it's really hard to detect all these features. And if you find one artifact, it could be already gone in the other video. So if you're interested in our approach, how we solve this critical time parameter problem, you should visit my talk tomorrow. Thanks.
Hello, I'm Fabrizia Bechtold and I'm with vrvis. There is so much we can learn from animals, and yes, but we can't communicate with them, so we mostly rely on data from experiments. And in my talk tomorrow, I will explain to you our solution on the solution we found on how to get knowledge and insight from rats in a T-maze, and we did this by designing a new interactive visualization.
Hi, my name is Zuzana. I'm studying at Slovak University of Technology in Bratislava. And actually, manual segmentation of medical images is time-consuming task, so we proposed automatic method for tumor brain segmentation from magnetic resonance images. First, cranium is removed, and then tumor is segmented using adaptive methods. Actually, first result shows that adaptive methods are suitable for tumor brain segmentation. Thanks.
Hi, my name is Robert Svirn. I come from University of Maribor. LiDAR data is 3-dimensional data representing, in our case, a surface from which we can extract simple objects such as buildings and terrain. And in our case, we want to enrich this information, not to know only where the building is or how big it is, but to know what kind of build-up the group of buildings represent.
Hi, I'm Marek from Brno, and I want to tell you something. Once my brother asked me to create an image for him, it's the top one. He called it Game of Alcatraz, and I struggled with it, and it took me more than an hour to create it. And I thought maybe there is a other way, maybe there is a better way. So I created the app, and now he's able to create his own images in a few seconds, just with that app. That's it.
Hello, I'm Irfan Prazna from University of Sarajevo. I will present you a novel solution for interaction with small 3D objects. There are a lot of solutions with their advantages and disadvantages. We will present another solution which is web-based. It uses leap motion as a sensor, and it allows users to grab and move 3D objects like they would move real objects. Okay.
Hello, my name is Ondrej Jarjabka. I'm from Comenius University, and what we are trying to do is ease the pain of the students to create a lecture note, and we are trying to generate slides as images from videos where the lecturer is presenting his lecture, and our slides should only contain valid information from the lecture. So if you want to know how it's done, come to see my talk on Tuesday.
Hello, my name is Roman, and as you can see, I will be talking about simulating virtual agents into virtual cities. This is really important for game industries, urban planning, or simulating evacuations. For this model, I chose well-known model, social force model, and with other stochastic method, Monte Carlo, for more randomness. If you're interested, visit. Thanks.
Okay, I'm Karl from Graz University of Technology, and I'm here to ask you a question. Have you ever tried to create huge 3D scenes with thousands of models like a city or a whole galaxy, but you found out you didn't have infinite time? Then you should come to my talk on Tuesday, where I will talk about procedural generation and how to use genetic algorithms to control shape parameters and to create spaceships like these.
Hi, I'm Lisa from vrvis Research Center, and I'm presented guiding 2D modeling of 3D buildings. And in our approach, we use sketching in 2D, and which finally results in a 3D model. And as you can see in the video, you're directly sketching in the photos, and on the left bottom you have a guidance indicator which tells you if you're already done, and this all happens in combination with a point cloud.
Hello, I'm Marek Wronkowski and I'm from West Pomeranian University of Technology, and I'm going to talk about simulation and visual adaptation. So visual adaptation is a great way of improving the immersion in computer games, however it is very hard to really program in computer games, in real-time generated computer games. So we are trying to find out if using very complex models is really needed.
Hi, my name is Felix, I'm from TU Wien, and I'm going to show you how to find a resolution for your shadow map that hides artifacts. The two images you see here are actually generated from two different shadow maps. You have a couple of seconds time to find out which one is generated with only 1/4 of the resolution from the other one. Thank you. Oh, and if you want to know the answer, come by on Wednesday to my talk.
Hello, I'm Michał Chwesiuk from Szczecin, and I will talk about acceptable system latency for gaze-dependent level of detail rendering. Human eye is the fastest organ in our body, but it can be faked, so we can use its imperfections for speed up rendering. If you want to know how to do this, please come to my talk. Thank you.
Hi, I'm Patrick Stotko from University of Bonn, and objects can be reconstructed by moving around them with a Kinect sensor, and if you can achieve this in real time, then you can build exciting augmented reality applications. And in our talk, we will answer the questions, why do we need registration and what the current state of the art in this field is. Thank you.